We're about to look at the oldest light in the entire universe, a picture literally from the dawn of time itself. And you know, the story of how we found it? Well, it doesn't start with some big, grand discovery. It starts with a faint, super annoying noise that just would not go away.
So let me ask you, what do you think is the oldest picture ever taken? I can tell you, it's not some faded photograph from the 1800s. It's not a cave painting. It's way, way older than that. And the whole story of its discovery, it begins not with a telescope pointed at the stars, but with a weird constant hiss.
So, meet Arno Penzias and Robert Wilson. It's 1965, and these two guys are radio astronomers over at Bell Labs. They're using this enormous horn antenna, trying to map signals from our own Milky Way galaxy. But they had a problem. A really, really persistent problem.
See, no matter where they aimed that giant antenna, didn't matter if it was day or night, summer or winter, they kept picking up this faint, steady, mysterious hum. It was this background noise that just wouldn't leave them alone. It was coming from everywhere at once, and it was driving them absolutely crazy. They tried literally everything to figure out where it was coming from. Okay, was the equipment just faulty? Nope. Was it maybe radio interference from New York City? They checked. Wasn't that either. They even blamed something they called a white dielectric material that was coating the inside of the antenna. You want to know what that was? Pigeon droppings. Seriously, they cleaned it all out, and yet the hum was still there.
So what on earth was this signal? Well, they were able to measure it, and it was a microwave signal that had a temperature equivalent of about 3 degrees above absolute zero. Just a faint, cold, cosmic whisper. But a whisper of what?
Penzias and Wilson were totally stumped. They had accidentally found one of the single most important clues about the origin of our entire universe, but they had no idea. And to get why this was so huge, we have to rewind a bit and look at the big cosmic debate that was raging in the 1960s. So on one side, you had the steady state theory. This idea basically said the universe has always existed and it always will exist, looking more or less the same. Then, on the other side, you had the Big Bang Theory, which said no, our universe exploded into being from an unbelievably hot, dense point, and it's been expanding and cooling off ever since. I mean, you couldn't get two more different ideas about everything.
And it turns out that annoying hum that Penzias and Wilson found, that was the final knockout piece of evidence that would settle this debate once and for all. Just like physicist Ruth Durer said, this discovery was a total game changer, because that background noise, it wasn't noise at all. It was a signal. In fact, it was the echo of creation itself.
And you know what's really wild about all this? Scientists who backed the Big Bang Theory had actually predicted this thing existed. Years earlier, physicists like George Gamow had argued that if the universe really did start in some hot, dense state, then there should be some leftover heat, some relic radiation still bouncing around the cosmos. And Penzias and Wilson, they just found it, completely by accident.
So what exactly is this echo? Well, the best way to think about it is as the universe's very first baby picture.
The official name for this signal is the Cosmic Microwave Background, or CMB for short, and it is, for all intents and purposes, a snapshot of the entire cosmos when it was just a baby, only about 300,000 years old. It's the oldest picture we could ever take. But why is that?
Well, because before this moment, the universe was so incredibly hot and dense that it was basically like a thick, glowing fog. It was this soup of charged particles, protons and electrons, that just trapped light. A photon of light couldn't go anywhere without getting bounced around. But as the universe expanded and cooled, atoms finally formed, that fog cleared, and for the very first time, light was free to travel across the cosmos. And that light, that ancient light, is what we see today as the CMB.
But here's the thing. This baby picture is way more than just a uniform glow. Because when we look closer, that's where the real secrets are hiding. So the CMB is amazingly uniform, right? Almost the exact same temperature no matter where you look, but almost is the key word here. There are these tiny, minuscule variations in its temperature. We're talking just 1 part in 100,000. And these tiny little ripples, they are everything.
Why? Because these slightly hotter and colder spots show us where things were a little more or a little less dense way back in the early universe. The slightly denser spots had a little more gravity, and over billions of years, that gravity just kept pulling in more and more matter. These tiny ripples, they were the seeds that grew into every galaxy, every star, and every planet we see today. That includes us.
So for decades, scientists were on the hunt for these tiny temperature differences. And then finally, in 1992, the COBE satellite found them. This is the first map they made. It might look like just a bunch of splotches, but this blurry image was revolutionary. It was the first time we could actually see the seeds of galaxies. Then, in 2003, we got an upgrade. The WMAP satellite brought that baby picture into much sharper focus, revealing this absolutely stunning, detailed pattern of those ancient seeds.
And then came 2013. The Planck satellite gave us this, the high-definition version, an unbelievably precise map of the infant universe. This isn't just a picture anymore. It's a blueprint for the entire cosmos.
And having this blueprint has let us figure out the fundamental recipe of our universe, like what it's actually made of. And the answer is pretty weird.
Yeah, by studying the patterns in the CMB, we figured out something astonishing. Everything we can see, all the stars, galaxies, planets, people, all of that only makes up about 5% of reality. The rest is made of two ingredients that we don't really understand at all. There's dark matter, which is like an invisible scaffolding holding galaxies together, and then there's dark energy, some kind of mysterious force that's actually pushing the whole universe apart.
And that's not all this one picture unlocked. It told us the shape of the universe. It's geometrically flat. It gave us strong evidence for a pretty wild theory called inflation, the idea that in the very first instant of its life, the universe expanded faster than the speed of light. Because of this single ancient echo, we can now measure the cosmos with incredible accuracy. It's the thing that turned cosmology into a true precision science.
So just think about that journey for a second. It all starts with some annoying static and, some pigeon droppings. That noise turns out to be the echo of the Big Bang. That echo becomes the universe's first baby picture, and that picture gives us the blueprint for the entire cosmos.
From a faint, persistent hum to a detailed map of our own cosmic origins, revealing ingredients and laws that we never even knew existed. It really makes you wonder, right? With new telescopes and even more sensitive instruments on the way, what other secrets are still hidden out there, just waiting for us in the oldest light in the universe?